All right, here's another PE HVAC question. The question states, the specifications for a compressed air system at 75 psi gauge and 70 degrees Fahrenheit require a dew point of 50 degrees or lower. Under these conditions, the maximum allowed humidity ratio of the compressed air is most nearly what? So your first inclination when you see this question might be to find 50 degrees on the psych chart, find where that hits the dew point, and then use that to find the humidity ratio. So if we go to our handbook, go to our psych chart, find 50 degrees, run that up to your dew point, and then run this guy over to the right-hand side. This will give you your humidity ratio. If this was at atmospheric pressure, we could grab the number here and that would be our answer. However, our question is not at atmospheric pressure. It's at some pressure higher than atmosphere. So we can't use this equation. Instead, we need to use, or we can't use this chart. Instead, we need to use an equation. So if we go to our psychrometric properties, there's an equation in here that we can use. It's this guy here, saturation humidity ratio. But to use this equation, we need to find the vapor pressure and the total pressure. Thankfully, we can find both these guys. So if we go back to our question, it gives us a gauge pressure. We need to convert this gauge pressure into absolute pressure. So to do that, we're going to take this 75 and add on atmospheric pressure, 14.7. That gives us 89.7 psi absolute. Okay, now we need to find the vapor pressure at 50 degrees. So if we go to our PE handbook and we go to steam charts, steam and temperature, you can see here at 50 degrees, our absolute pressure, which this is essentially our vapor pressure, is 0.18. So pressure vapor equals 0.18. So go back to our handbook. I'm going to grab this equation we're looking at. This guy. Grab that. So we're going to simply plug these numbers into this equation. So WS equals 0.622. We have our vapor pressure, 0.18. And then our total pressure, 89.7 minus 0.18. So I'm going to go ahead and plug that into my calculator. 0.18 divided by 89.7 minus 0.18 times 0.622. So this gives me an answer of 0.00125. But this is in pound mass of water per pound of dry air. And we need this in grains per pound. So we simply multiply this by 7,000. To get grains. So that will give us 8.75 grains per pound mass. And if we look over at our solution, it's going to be B, 8.7.